T2, day 24 of calculus. We are going to continue our examination of maxes and mins from word problems. So we're back to making a pen on the side of a wall, but in this case it's a barn. And we have 80 feet total. We have 80 feet total. So we already have our picture. So what do we know and what do we want? So first we know that the perimeter is going to be 80 feet, but we also know the perimeter is, we have an x and another x over here, so it's going to be 2x plus y. And what are we supposed to do here? We're supposed to find the dimensions of the pen that maximize area. So we're maximizing area right here, so we want max area. What are the dimensions that maximize area? We want the dimensions that do that. So if we're looking for area, we need to make sure we have an equation for area, and the area of that pen is just going to be x times y. But before we can take the derivative and set it equal to 0 to find where the max could occur, we need to make sure that this is down to one variable. We're going to do that by taking these two equations and combining them, and we know therefore that 80 is 2x plus y. So let's just subtract 2x. So we know that y is equal to 80 minus 2x. We're going to plug that in right there. What that gives us is a equals x times 80 minus 2x, and now we're down to one variable, just x. So now we're going to take a derivative, but before we do that, let's clean it up a little bit. So we have a in terms of x is equal to 80x minus 2x squared. Therefore, we can now take the derivative. So a prime of x is equal to 80 minus 4x, and we set this equal to 0. We set it equal to 0, we end up with 0 equals 80 minus 4x, so 4x is equal to 80, so x is equal to 20. We need a sign diagram to show that that's a maximum, and we do that as follows. We have 20x and a prime of x, and our derivative, that's nice, is 80 minus 4x. So let's plug in a number to the left here. Plug in 10, and you end up with being positive. Plug in 30 over on the other side, and it's negative. So what's going on here? It's going up and then down. It's a pretty bad up and then down. It's going up and then down, so it's going to be a max. So if we want to find what the max area is, we can plug it in there. So a of 20 is going to be 20 times 80 minus 2 times 20. So that's going to be 20 times 80 minus 40, which is 20 times 40, which is 800. That's nice. If we wanted to know what the dimensions are, though, so that's the max area. So what are the dimensions, though? Well, we know that y up here, y is equal to 80 minus 2 times x. So y when x is 20 will be y when x is 20 will be 80 minus 2 times 20. So that's 40. So that's the max area, and it occurs when x is 20 and y is 40. Key thing to note here, the side of the barn, they told us it's 100 feet on the side, and that didn't come into play here, but that basically tells us that if we go over that, we lose that side of the barn. So let's move on. So we're going to have the same situation here. We have the side of a barn, but in this case, 3 pens are going to be made. There's 3 of them. So when we write down what we have a picture, what we know and what we want, we know that the overall amount of fencing is 80. But now how many x's do you see? I see 4 of them. So we know that the perimeter of fencing is going to be 80 feet, but now we also know the perimeter is 4x plus y. And we want, what do we want here? What dimensions for the total enclosure make the area of the pens as large as possible? So again, we're maximizing area, large as possible. So again, area, though, is going to be still x times y. We're assuming that the width of the fence does not come into play. So we're assuming that this still is the area of the pens put together right there. So the area is still x times y, and we want the, what is the max area? And we want the dimensions for that. We want the dimensions for that. But like before, we can't just take the derivative of this because it's in 2 variables. So we need to isolate y right here. We'll combine those two first and then isolate y. So we know 80 is equal to 4x plus y. So y is equal to 80 minus 4x. We're going to plug that in right there. And what do we end up with? Area in terms of x will be x times 80 minus 4x. So a of x is 80x minus 4x squared. We now have it in one variable, so that means we can take the derivative. So a prime of x will be 80 minus 8x. So we set it equal to 0. And we get 8x equals 80. So x is equal to 10. But again, we need a sign diagram, x and a prime of x. We know that that's 0. We have two sides here. We have this side, we have this side. And when you plug in, let's say 5 into our derivative is, what's the clean nice derivative right there? Plug in 5, you will get a positive number. Plug in 15 and you get a negative number. So it's rising and falling. It is a max. So what dimensions? Well, x is going to be 10. If we want y, we know y is equal to 80. So y when x is equal to 10 is 80 minus 4 times 10. So that's 40. So the max area is when x is 10 and y is 40. And you can check to see if this works. 4 times 10 is 40, 40 plus 40 is 80, so it's all of it. So now we're going to put the pen up against the side of the barn, but the pen is going to be potentially wider than the barn. So it says that suppose that Farmer Brown has 180 feet of fence and wants the pen to adjoin, so that like this, adjoin the whole side of the barn as shown in the figure, meaning it's got to cover the whole side. What should the dimensions be for maximum area? So we know and want, we already have the picture. So we know that the perimeter is going to be a total of 180 feet. That's nice. And we have an X right here. And we know that the barn has a side length of 100. It doesn't explicitly state it, but it's the same barn as before. So we know that this right here is 100. So if we want the fence is the yellow right here as I draw it. We already have pieces of it here. We have X and Y and X. So what about this distance right here? Well, that distance is Y minus 100. That is Y minus 100 right there. So that's the first thing you have to notice. So what's the perimeter all the way around? Another way to write the perimeter, there's two x's, there's a y, and there's also a y minus 100. So what do we want? We want to know max area. We want to know what the dimensions are so that we have the maximum area. What are the dimensions? So we're doing the same thing as before. We write our area function, which is just x times y. And realize again that we can't differentiate that right now because it has two variables. So we're going to combine these two right here. And when we combine them, what do we get? 180 is equal to 2x. And how many y's do you see? I see 2 of them. And then you have minus 100 right there. So you add it and you get 280 equals 2x plus y. 2y. Let's divide by 2 and you get 140 equals x plus y. So let's solve for y. We get y is equal to 140 minus x. So we can take this now right here and plug it in right there. What does that give us? Area just in terms of x, which is x times 140 minus x. So now we are on cruise control for a little while at least. We distribute, we set it equal to 0. And excuse me, we don't set it equal to 0 yet. We take the derivative first. So a prime of x is equal to 140 minus 2x. Set it equal to 0 to get 140 minus 2x equals 0. So 2x equals 140. So x is equal to 70. So this is where we have to pause for a second because we have to go back and look up here. It says note that x has to be between 0 and 40 in this case. And why is that? Why is that? Well, if x was any bigger than 40, you run out of fencing. You don't have enough fencing to do this. What I mean by that is, let's say this was 40 and this was 40, like that. If that was 40 and 40, you have 180 feet of fencing total. You want to totally cover this side right here. So this distance right here, y would be 100. Well, 100 plus 40 is 180. So x has to be between 0 and 40. So this is not in the domain. X can't be greater than 40. So what does that mean? Well, it means we need to do a little bit of more analysis here. So let's take this function right here, a of x, right here. And an easier way to look at it is actually look at the original one. What are the intercepts? Well, it's intercepts at 0 and 140. And what does it look like? Well, it goes up and then it goes down. And we know that the max occurs at 70 if we had that much fencing, but we don't. What happens though is we look at what happens as x gets bigger, closing in on 70. Well, we know x can go from 0 to 40. So if this is area right here, where is area maximized from 0 to 40? It's maximized right there. That's as high as it can go, and that's going to happen when x is equal to 40. So the key here is to know what your domain is. know what your domain is. You're not always going to be given this blue nice thing right here, but you need to realize it. So in this case, the max happens when x is equal to 40. So if x is equal to 40, how can you find y? Well, you know y is equal to 140 minus x, so y is going to be 100. So it asks, what should the dimensions be for maximum area? 40 by 100. And in that case, the pen would just be like that. So we're going to do the same thing, but instead we're going to cover this L-shaped barn right here. It gets a little different here. So we're going to do the same thing we did before. We have what we know, and we want to write down what we want. So let's finish this perimeter right here. We know that this perimeter of fencing here, let's look in the problem. It should tell us how much fencing we have. We have 80 feet of fencing again. That's nice. So we need to write an equation here so we know that the perimeter is 80. So we have an x right there, and this is 40 right here. So this right here, that right there is going to be y minus 40. And if that right there is 20, this right here is going to be x minus, no, not x equals 20, x minus 20. So how many pieces do we have here? We have the x minus 20, the y, the x, and the y minus 40. So we know that that perimeter is going to be x minus 20 plus y plus x plus y minus 40. So those are the three things there. You have the y minus 40, the x, so the y minus 40 and the x, the y right there, and the x minus 20. So you want to maximize area again. So again, we're looking at a equals x times y. But again, we can't differentiate that yet because we need to substitute in. What we learned in the last problem was that we have to be careful about the domain. What are the minimum and maximum values for x? So before we go any further, let's figure this out. X can't be bigger than something, and y can't be bigger and less than something. So we need to figure out what the biggest value y can be, what the biggest value x can be, what the smallest value x can be, and the smallest value y can be. So assuming we cover this entire side, x has to be at least 20. And assuming we cover this entire side right here, which we do, it has to be 40. What's the biggest? What's the biggest it can be here? Well, if you keep this at 20, how far out can you go? How far out can you go and still be 80? So if this is 40 and 20 right there, that's that's going to be 20 right there. So what's the biggest you can make this? Well, if you play around with it, you figure out it can be 50 right here, because if this is 50, if that's 50, the fencing would be this red part right here. You see that right there? So that would be 10, 20, and 50 is 80. So the biggest y can be is 50. What about for x? Well, the biggest x value would occur when we make the fencing all the way around like this. So you'd have x would be, if you're really careful about this, you'd have a 40 right here for that distance, because that distance has to be covered. So you've already used 40 of them, and then you have x and x minus 20, and it turns out the biggest x can be is 30 on this side, because if it's 30 there, it's 10 here, because it's 20 less. 40 plus 10 is 50, 50, 60, 70, 80 right there. So the biggest it can be is 30. So now you keep going. You do the same thing you did before. You take all of this and you simplify it. So what does that mean? How many x's do I see? I see 1x and 2x, so that's 2x. How many y's do I see? 2 of them. And then you have minus 20 and minus 40, so you have minus 60. But you know the whole thing is equal to 80. So you have 2x plus 2y minus 60. So 140 is equal to 2x plus 2y. Divide by 2, 70 equals x plus y. So y is equal to 70 minus x. And this is where we plug it in right there. What do we end up with? Area in terms of, this will be in terms of y now, that's fine. It's just one or the other one. Area in terms of y is going to be not a, it's going to be, it's area in terms of x. Ooh. It's going to be x, and we're replacing y with 70 minus x. So you get a of x is equal to 70x minus x squared. So you end up with area in terms of x, if you do the derivative, is 70 minus 2x. Like before, we set it equal to 0, 70 minus 2x, not 20, 70 minus 2x. So x is equal to 35. But what we notice is that it can't be in there, it's not in there. So let's take a look at our domain again, or let's look at the area function like we did in the last one. And we're going to look at this nice factored one. It crosses at both 0 and 70. And it goes up and then it goes down. And where does the max occur? Well, 35. We can do a sign diagram to show that. So what happens when x is between 20 and 30? So let's say 20 and 30 is going to be right here. From 20, not to scale, to 30. If it's increasing from 20 to 30, where, and remember this is area, where is the area maximized? It's maximized right there. So it's going to be maximized when x is 30. Correlates to that point right there. So if we wanted y at that point, well, y is equal to 70 minus x, so y is going to be equal to 40.